So in scientific notation, there are a few rules. The first rule is you must have one digit before the decimal. If it doesn't have one digit before the decimal, then it's not in scientific notation. When you're going from scientific notation to standard, a positive exponent means move the decimal to the right, and a negative means move to the left. For example, right here, I have 1.028 times 10 to the ninth. This positive 9 means I'm going to take this decimal and I'm going to move it 9 times to the right. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. If you notice, I've got 1, 2, 3, 4, 5, 6 places that do not have numbers there. I'm going to have to fill those in with zeros. So 1, 0, 2, 8, and then 6 zeros. 1, 2, 3, 4, 5, 6. And I can go back and put in my commas. So that's 1,028,000,000. This one, on the other hand, has negative 11. That means I'm going to move 11 places to the left. So I'm going to have to rewrite that one, 5.61, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places I need to fill in with zeros. So that's 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros, and then 5, 6, 1. On the other side, when we're converting from standard form to scientific notation, we have to remember our rule. It's one digit before the decimal. So if I need to get, so there's one digit before the decimal, I need to find my first non-zero digit, which just happens to be 5 in this one. I need to count how many decimal places do I need to go to get from here to there. So 1, 2, 3, 4, 5, 6. So I have 5.6 times 10 to the. When I turn this back into standard form, I need to go to the left. So that means I need to write it as a -6 so that I know when I go back the other way, it's the left. So 5.6 times 10 to the -6 is equal to this 0.0000056. When I look at the next example, I have 90,825,000. On a whole number, the decimal starts right at the very end. The first non-zero digit in this number is the 9. So I need to count decimal places. 1, 2, 3, 4, 5, 6, 7. So I'm going to write 9.0825. And because these zeros would just become placeholders, we don't need to put them. So 9.0825 times 10 to the, and we said that was 1, 2, 3, 4, 5, 6, 7 hops. So that's 10 to the 7th. This 90 million is a really big number. So that means it's going to be a positive. That's another way to know whether it's positive or negative. If you're converting a really big number, this has to be a positive exponent. If it's a really small number like this one, then it has to be a negative exponent. Because this 7 means that when I go back the other way, when I convert it back to standard form, I have to move that decimal 7 places to the right to create that really big number. So we'll do 2 more examples. Again, the decimal on a whole number starts at the back, and the first non-zero digit is the 7, so we have to go between the 7 and the 4. That's 1, 2, 3, 4, 5. So that's 7.45 times 10 to the 5th. And because that is a really big number, we need to move this decimal back to the right to go back to standard form, so that's a positive 5. The last example, The first non-zero digit is a 3. So I need to change this so that it's 3.77. So I'm going to start here and count my hops. 1, 2, 3, 4, 5, 6, 7, 8. So that's times 10 to the negative 8. And again, it's negative because this is a really small number. And when I convert this back to that number, this decimal has to move back to the left. So negative 8.